Coders. Welcome to my YouTube channel. Today we'll see the next question in our LeetCode 75 list, and we have reached till prefix sum, and now we'll see the next question, that is the second question in our in prefix sum of LeetCode 75. So let me take you to the screen, and yeah, this is the next question. We have solved this one, that is the find highest altitude. Now we'll see the find pivot index, and let's see what is it. The question is, given an array of integer nums, calculate the pivot or pivot, whatever you says. I said pivot, and pivot index of this array. The pivot index is the index. Basically they have given the, what does it mean pivot index? It is the index basically, uh, from which the number strictly to the left of this index is equal, like sum of the numbers which are strictly to the left. Basically strictly means we are not including that index number, that not including that number. It is basically strictly to the left and strictly to the right. So excluding that number, whatever the numbers are the left, the sum of that numbers equal to the sum of the right numbers. It's saying that only. And we need to find such index whose left sum is equal to right sum, excluding that index, and return the leftmost pivot index. Okay, there could be more than one pivot indexes, and in that, like, there could be more than one pivot indexes, but they want leftmost only. So how we can solve it? We can solve it using prefix sum and suffix sum. Like prefix sum means add the numbers uh, from starting, and suffix sum means add the numbers from ending. So basically what I was saying, I was saying the, if you have 1 2 3 4 5, then in prefix sum, I'll say the, let me take it like this, and this is the prefix sum, and prefix sum will say this is 1, then 1 plus 2 is equals to 3, then 3 plus 3 is equals to 9. Oh, sorry, 6, sorry, I did 3 cross 3. 3 plus 3 is equals to 6, then 6 plus 4 is equals to 10, then 10 plus 5 is equals to 15. This will be our prefix sum. But what is the suffix sum? We in suffix sum we come from last to first, like from right to left. So we'll go from end to the start. At the end, the sum is 5. Then we'll do 5 plus 4, which is 9. Then we'll do 9 plus 3, which is 12. Then we'll do 12 plus 2, which is 14, and then 14 plus 1, which is 15. At the end the sum is same only, cause we took the same numbers. You can see that here 15 and 15. But the method is in first, that is in prefix we are going from starting, and in suffix we are coming back from back only, from right to left. With the basically in prefix we go from left to right, and in suffix we go from right to left. Okay, now you understood what is prefix and what is suffix. So how we can use that concept here? I'll say ki I'll maintain the prefix sum, I'll maintain the suffix sum, and on that index we'll see ki if the prefix sum is equal to suffix sum, then yes, uh, we can say ki yeah, that is the index, that is our pivot index, we can say that. So yeah, let's see how we can solve that. uh, take, take this example that they have given, this array, and we'll go like and on first index we have left sum is equals to 0. Like left sum means I'm saying it's prefix sum, that its prefix sum is 0 for the 0th index. For second index, basically I'm storing that sum on that index, and then I'm adding a number on that index, and then I'm storing that sum for the next index. What I said, let's write me this. For 0th index, let me write the indexes here, like on above this. This is 0, this is 0, 1, 2, 3, 4, 5. Okay, for 0th index I'll say ki I have 0 sum, but I'll add that sum to the 1. Then I have 1 sum, then I am adding 1 to the 7, that is 8. Then I am adding 8 to the 3. Basically, I took 0, then like 0 plus 1, 1, then 1 plus 7, 8, 8 plus 3 is equals to 11, 11 plus 6 is equals to 17, 17 plus 5 is equals to 22, 22 plus 6 is equals to 28. Yeah, I did that, and now I'll do the same for the suffix. For suffix, I'll come from the last, and for the last thing, I'll take the 0 for the last index, then I'll add the 0 to the 6, it will be 6, then I'll add 6 to the 5 here, like this. For this I'll take 0, 0 plus 6 is equal to 6, then 6 plus 5 is equals to 11, then I'll take the 11 plus 6, that is 17, and then I'll take 17 plus 3, which is 20, then 20 plus 7, which is 27, and then I have 1, that is 27 plus 1, which is 28. So let me rearrange this, like this was the 0, 1, this was the 0th index, and then this, and this, and yeah, now it's look good. So for the 0th index, for the prefix sum I have 0, and for the suffix sum till the 0th index I have 28 sum. Then I have, for the first index I have 0, like for one sum, then I have 27. For this I have 8, then 20, 20. For this I have 11, then 17. Let me do this. Okay, so this one and this one. So basically they were saying excluded, so I didn't find key index in on which it is same. But what we can do here, key, I think I took this 0, but what if I took it as it is, like if I'm on that index, then my sum is 1, then on if I'm second index, then 1 plus 7 is 8, then 8 plus 3 is 11, then 11 plus 6 17, 17 22, and 22 and 6 28. Likewise, and if I'm at last index, then also it is like this only, like first it is 6, then 11, then 17, then 20, then 27, and then 28. If I do this, then what I can see, key, I have this. For third index I had 20 sum from right to left, and for this index I have this sum from this ways. So what I can do here, for this index it is saying it is 17, it is 17, both are same, but I don't want to include that number in it. Like I have to exclude it. Like if I exclude say 6 from it, then it become 11, and if I exclude 6 from this, it's become 11 again. So yeah, we can do like this, key, let's take suffix sum this, then suffix sum this, like prefix sum this, then suffix sum is this, and then we can add that like subtract that number and check key if it is equal, cause we want to exclude that number, and for that index, for this sum we have included that, so we can exclude on that number, like when I'm that on that index, then just subtract that number from both prefix and suffix and check if now the both are if they are both are equal, then that is the index that I want have to return. So let's see if it works. It should work because we just saw on that number, like we on that array. So let's declare vector. Let's take first size for that vector, because we will declare the prefix sum and suffix sum vector of that size only. Prefix sum, we can take int, yeah, we can take int because not exceeding like 100, like 1000, 10 raised to 3 into like 10 raised to 4 numbers are the 10 raised to 3, then it max go 10 raised to 7, and it can be it can be included, like it can be fit in int, so we can take it. We can take the prefix sum, so let's say it is okay, let me take it prefix sum. and prefix sum of n with 0, and the same but we'll take for the suffix sum. Whether we can do it in another method also, that we'll see in next video, cause it will take a long time if I include it here only. Okay. Suffix sum, and we'll see. Let's see, first prepare data, like first we'll prepare means we'll prepare first prefix sum array, then we'll prepare first suffix sum array, then we'll go, then we'll then we'll do actual thing, like we'll find the actual thing that they want a pivot index, so we'll find that less than in a plus plus, and our prefix sum will be prefix sum on that index, just add it, like prefix sum for the index, let's start it from 1 because I have to include the last number also, and prefix sum for the 0 is num set 0, and prefix sum for the 1 is equals to prefix sum at previous and include that number, basically prefix sum at previous plus num at that index, this is this. And for the suffix we'll do the same, suffix and suffix sum. Okay, it is suffix sum, and for that we will go from right to left, so we'll take the last number first, and we'll go from n minus 2 to n I should be greater than or equal to 0, and we reduce the I, and here it should be plus, and prefix sum should do it prefix sum, and yeah, now it's look fine, and let's see if it works. I is less than n, and if my prefix sum at that index, I don't want to include that number in prefix sum either or in suffix sum either, so it should be equal to suffix sum at that index minus nums at that I. If it is, then we'll return that index. So here they have written 0 1 2 3, okay, third index only, 1, okay, they have written I only, okay, we'll also return I, and if I don't find anything, then I'll return -1 and just submit it. We'll see. Yeah, it passes. But what happens here? We have completed it in big of n time, because this will take big of n, this will take big of n, and this will take big of n. Basically, though it is taking big of n plus n, like 3n, we'll say it total time complexity for this question, like for this solution, is big of n, and space complexity is also big of n because we are storing two arrays, like big of 2n basically, but in general we say big of n. And can we reduce the space complexity here? That's what my question is, and I solved it using this, like I solved it using big of n because I wanted to tell you we can solve this question using prefix sum and suffix sum concept. But yeah, using the same thing, but we can reduce the space, and that we'll see in next video. So yeah, if you like it, then like, share and subscribe. Bye.